input. Now the topic is a digital frequency counter. Here the digital frequency counter. First we have to know what is called a frequency. Frequency is a cycles per second. I mean, now in our country we are having a power frequency of 50 hertz per 50 cycles per second. That is called a frequency, or F equal to 1 by T, time period frequency, or T equal to 1 by F. It's a frequency. Frequency is nothing but a cycles per second. Okay, the basic principle behind the frequency counter is following. Basically it consisting of a two input AND gate. One input of an AND gate is given by the train of pulses. These pulses are obtained from the signal whose frequency to be measured. See, the basic concept is shown here. Here simply it consisting of one AND gate. AND gate, we know that AND gate, two input of the AND gate is 1 1, the output is 1. That is the basic concept. So that will be used here. The frequency to be measured, that will be converted, that is sinusoidal is converted into train of pulses, that will be given to one input. Another one input, that it is a time period, that is 1 second will be given. So 1 second it will be maintained a constant. The train of pulses will be there. This will be maintained 1 for 1 second. Here how much, suppose 50 cycles means 50 positive cycles will be there. So the AND gate output is 50 ones. So this 50 number of pulses will be counted by a digital counter. Okay, that will be the, we can count that frequency 50 cycles per second. Suppose we are having 100 means 100 pulses, 100 output will be there. That this 100 pulse will be used to counted by counter. So 100 cycles per second. That is the basic concept behind the frequency counter. We can see the block diagram of a digital frequency counter. That is consisting of mainly 3 blocks. One is a gate flip-flop control. Another one is a main gate, that is this gate. Okay, main gate or a start-stop gate. This one is a time-based generator. Okay, time-based selector. Okay. Then the input signal whose input to be measured for the frequency is amplified through the amplifier. Here the input frequency, unknown frequency, then you are having amplifier, then it will be given to a Schmitt trigger. We know that Schmitt trigger, that it converts sinusoidal to square. Then that will be output of the amplifier is fed to a Schmitt trigger. It converts the input signal as a square wave with fast rise and fall times. Then it is differentiated and clipped. Finally a train of pulse or generated from the Schmitt trigger. The train of pulses which is to be measured for the frequency is act as a trigger pulse for main gate and or AND gate. It is referred as A. So the entire input signal to be measured is given to A of the main AND gate. Okay. One more input is referred as a B at the stop gate, which is from the gate control flip-flop. The gate control flip-flop receives the signals from the time-based selector. This is the input signal that it will be given to a of the main AND gate, and then another one is a B referred as a B input, that will get the input from gate flip-flop control. The gate flip-flop control receives the signal from time-based selector. Okay, then we can see how the gate control flip-flop is working. Positive pulses from the time-based selector are fed at the point B of the start gate and the point B of the stop gate. This is the time-based selector. Its output from time-based selector is given to the B of the start gate, B of the stop gate. Okay. Initially f of 1 is set. Initially this is a flip-flop 1. This is a f of flip-flop 2. Initially f of 1 is set. Set means y equal to 1. Therefore this stop gate is enabled, that is a y equal to 1, y bar equals 0. Start gate is disabled, stop gate is enabled. Okay, that is given. Initially f of 1 is set y equal to 0, y bar equal to 0. The y of the f of 1 is connected to a of the stop gate. Similarly, y bar of the f of 1 is connected to a of the start gate. Therefore, the start gate is disabled and the stop gate is enabled. The output of the start gate is fed to s of the f of 2. F of 2. The start gate is output is given to or some output of the stop gate is given to s of the f of 2. Since the y bar of f of 2 is connected to b of the main gate, the start, stop or a gate counter is disabled. Since initially the stop gate is enabled, start gate is disabled. Set y equal to 1, y bar equal to 0, b is 0, so it is in off state. Main gate is disabled. Okay. Now we can how the count will be started. To initiate the frequency counter operation, positive pulse is given to r of the f of 1. Read input. Read, that is here r means reset, s equal to set. Whenever the input given is to r, reset, that is r is the y equal to 0. Okay, y equal to 0 means stop gate is now disabled, y bar equal to 1, start gate is enabled. Okay, start gate is enabled. The output of the start gate is given to r, that is a reset. Okay, therefore y equal to 0, y bar equal to 1. Now start is initiated. Therefore the stop gate is disabled, start gate is enabled. The output of the start gate is connected to r of the f of 2. At the same time, it is also connected to s of the f1. So once it is start gate is enabled, stop gate is disabled, this start counts. At the same time, it also connected to s. Therefore, set means now y equal to 1, y bar equal to 0. Once the start pulse initiated to count the input, start gate is disabled but stop gate is enabled because this output is given here. Okay, that is a set. Okay, therefore the output of the f of 2 is y0, y bar equal to 1. The output of f of 1 flip flop 1 is y equal to 1, y bar equal to 0. Thus the stop gate is disabled and the stop gate is enabled. Since the b of the main gate 1, y bar equal to 1 of the f of 2, the main gate start to count unknown frequency of the a of the main gate. After the specific time period, the base selector switch 1 second, 1 microsecond or anything selected based upon the position. This 1 microsecond, 10 microsecond divided by 10 and so on. Finally we get a 1 second. Here you are having a switch. Okay. Then after a specific time, then it goes to low. Here 1 second is over, that is consisting of a positive cycle and negative cycle. Again the next clock will be, next cycle will begin. Okay. As soon as the next pulse from the time base selector, the s of the f of 2 is 1. F of flip flop 2 changes its state from y0 to y equal to 0, y bar equal to 1 or y equal to 1, y bar equal to 0, since the stop gate is enabled. Okay. Once the start is enabled, start gate is disabled, stop gate is enabled. Here the b input is changes. The start gate is disabled, stop gate is enabled. Therefore, next cycles comes, this state will get changes. S equal to now 1. So 1 means this one is 1, y equal to 1, y bar equal to 0, y bar equal to 0, y equal to 1, y bar equal to 0, since the stop gate is enabled. Therefore, b of the main gate is 0, the main gate stops the counter. Thus, the counter counts the number of pulses occurring between the successive pulses from the time base selector.